Hello guys, Prathvik this side. So today we'll be solving our LeetCode question 153. Find minimum in rotated sorted array. So let's first understand this problem. Suppose we have an array of length n sorted in ascending order and is rotated between 1 and n times. For example, the array num 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times and so on and so on. So we given the sorted rotated nums of unique elements, we have to return the minimum element of this array. And we must write an algorithm that runs in O log n time. So the lead code problem is saying that we have to return the minimum element of this array after the rotation has happened. So the basically we can understand that we have to return the minimum we have to return the minimum element of this array after the sorted. So if we have to return the minimum, we can basically understand that it doesn't matter if the array is sorted or rotated. We just simply have to return the minimum. As you can see, 1 is minimum, 0 and 11. And we can clearly do it in one line, but the lead code problem is saying we have to do it in O log n time. And our problem is also saying that it is sorted at first after rotated. So these both points to our binary search of method. So what we'll do is we'll do it with binary search here. And since our array is rotated, it means only one half of the array is sorted. And in this question, what we have to do is we will just remove that sorted part because our minimum element cannot be in that sorted part of the array. So let's start with our binary search approach. I'm going to start in left equal to 0. I will start by making our two pointers. So, and then we'll start iterating in our array. Yeah. Now I will create my mid variable which will contain our index of middle element. Okay. And then we'll start by comparing it. If nums mid is less than nums right, then mid is equal to then right is equal to mid, or else left is equal to mid plus 1. So what I'm basically doing here is I'm checking which part of the array is sorted. Because if nums mid is less than nums right, that means our right part is sorted and we will just put right is equal to mid. And why I'm putting right is equal to mid here? Because mid can be our our smallest element here. But if our nums mid element is greater than our nums right element, it means the left part which will have our the right part will have our smaller element. So I'll simply just increase our left. I will just discard our left side of the array and continue searching on our right side. So I'm doing this here is because left is equal to mid plus n, and why I'm not writing here is left is equal to mid because mid cannot be smaller element anymore. And after doing this, we'll just return our nums left element. So this is basically it, and let's check if it is working or not. As you guys can see, it is passing all the test cases. So let's see if it is passing all the edge cases of it too. And our time complexity of this is O log n as our lead code problem wanted, and our space complexity is O1 since we haven't used any another data structure. So that's it for my side. We can also do this problem with only one line because basically this problem wants us to return the minimum element of this array, and we can just ignore the other part that it is sorted and rotated. And that's it for my side, guys. Thank you very much.